Kubernetes Container Network Interface (CNI) is a specification and set of libraries for configuring network interfaces in Linux containers. CNI is essential for providing network connectivity to Kubernetes pods, allowing them to communicate with each other and with external services. Here's a detailed explanation of Kubernetes CNI. What is CNI? CNI is a framework to configure network interfaces in Linux containers. It was originally developed by CoreOS and is now maintained by the Cloud Native Computing Foundation, CNCF. CNI focuses on network connectivity and includes a specification for writing plugins to configure network interfaces. How CNI works in Kubernetes. In Kubernetes, CNI plugins are used by the kubelet to set up networking for pods. When a pod is created, the kubelet invokes the CNI plugin to handle the networking aspects, such as assigning an IP address to the pod and setting up routes. Key components of CNI in Kubernetes. CNI plugin, a binary executable that is responsible for setting up and tearing down network interfaces. CNI configuration file, a JSON file that contains configuration information for the CNI plugin. CNI daemon, some CNI implementations include a daemon that manages the network state. Common CNI plugins. Flannel, a simple and easy to configure plugin that provides Layer 3 network connectivity using Flannel, HostGW, or other backend modes. Calico, provides networking and network security using IP routing. It supports network policies for fine-grained control over pod communication. Weave, focuses on simplicity and ease of use, providing a flat network topology that supports multicast. Canal, combines Flannel and Calico to provide a simple network plugin with policy enforcement. Cilium, focuses on security, visibility, and performance using BPF, Berkeley Packet Filter, technology. Contiv, offers networking for various use cases, including policy and micro-segmentation. Kube-router, uses BGP for routing and provides network policies and service proxy. CNI plugin installation. Here's an example of how to install the Calico CNI plugin. Install Calico. Kubernetes apply https://docs.projectcalico.org/manifest/calico.yaml. Verify installation. Kubernetes get pods and Kube system. You should see Calico pods running in the Kube system namespace. Configuring CNI. The CNI configuration file is typically located in /etc/p/net.d/. Here's an example configuration file for Flannel. JSON. Name, Flannel network. Type, Flannel. Subnet file, /run/flannel/subnet.env. Data dir, /var/lib/kni/flannel. Delegate. Is default gateway, true. Understanding CNI networking in Kubernetes. Pod-to-pod communication, CNI plugins ensure that pods can communicate with each other across nodes in the cluster. Pod-to-service communication, Kubernetes services provide stable IPs and load balancing for pods. CNI plugins help route traffic from services to the appropriate pods. External communication, CNI plugins handle traffic to and from external networks, including ingress and egress traffic. Advantages of using CNI. Modularity, CNI provides a standardized interface for networking, allowing for a modular and pluggable architecture. Flexibility, with various CNI plugins available, you can choose one that best fits your network requirements and constraints. Interoperability, CNI plugins are interoperable with various container runtimes and orchestrators, including Kubernetes. Summary. CNI, a framework for configuring network interfaces in Linux containers, essential for Kubernetes networking. CNI plugins, implement network connectivity and policy for Kubernetes pods. Common plugins, Flannel, Calico, Weave, Canal, Cilium, Contiv, Kube-router. Installation and configuration, involves applying plugin manifests and configuring CNI files. Pod communication, enables pod-to-pod, pod-to-service, and external communication within Kubernetes clusters. By understanding and implementing CNI, you can ensure robust and flexible networking for your Kubernetes clusters, facilitating seamless communication between pods and external services.